let us draw the rails first. So you have got the two rails, take down A and B. I mean, rails means two parallel lines. Okay. So two parallel lines A and B. That is called rail, on which a rod is kept. Let me assume this is the rod PQ. Now we have connected the rails to the circuit like this through the galvanometer, where you can read the current, and you got the key alignment here. Then it is connected. Now what is the direction of this rod? It is in this direction. Let me say this is x-axis, y-axis, z-axis. Okay, x, y, z. So along x-axis, the rod is moving, and along the z, you are able to get the magnetic field. Okay, and then you have got the y-axis, where you have kept the rod like this. Now, so they are mutually perpendicular to each other. Okay, so the magnetic field is going like this. Okay, do you understand this? The magnetic field is traveling vertically. Okay, and what about this y? This is the PQ, and z axis is the magnetic field. So you can put magnetic field here. This is the rod movement, and this is the direction of rod. Okay. Now the first question. What is the first question? We have to give the polarity, and before that, let us try to give the uh, given quantity. What are the parameters given here? What are the parameters given here? What are given here? Length of the rod. Take down L. So PQ is equal to L. So the length of the rod is how much? 15 centimeter. So 15 centimeter means 15 into 10 power minus 2 meter. Right. And then what is the magnetic field? B. Yes. So 0.5 Tesla. And then a resistance is given. How much? 9.0 milli ohm. That is equal to 9.0 into 10 power minus 3 ohm. Then speed is given V. So V is equal to how much? 12 centimeter per second. So let us convert this into meter per second. So 12 into centi means 10 power minus 2 meter per second, right? Okay. Now the first one, when the switch is open, the rod moves with the speed. So it triggers some charge. Okay. So this is the induced EMF. What is the formula for induced EMF? E is equal to how much? B into V into L. So this is the first formula you are going to use. So induced EMF is equal to B into V into L. So what is B? 0.5 into what is the velocity here? 12 into 10 power minus 2 meter per second. And then what is the, L, length? 15 into 10 power minus 2 meters. So get me the answer for this. Do it first quick. How much? So 9 into 10 power minus 3 volt. So that is nothing but 9 millivolt. Okay. So this is the induced EMF. So we have done the first one. Okay. Then what is asked when K is open? Second question. When K is opened. Okay. When K is opened. Rod moves with the speed 12 centimeter. That is over. When the K is open, upper end of the rod. Okay. The upper end of the rod becomes, upper end means what? P. At P. Take down. At P, it becomes positively charged. So if it is positively charged, then lower end becomes negative. That's it. So that's what they asked. What about the charge? And when K is closed, when K is closed, then the charge flows in closed circuit. Is it not? When the rod, I mean, when the switch is closed, what happens? The charge, I mean, the current is flowing through this. So the charge, that is current, flows through the closed circuit, but the excess charge is maintained. Okay, there will be excess charge. Take down. So the charge, write down, when K is closed, the charge flows in closed circuit. That is natural because we are closed the circuit. So when I say closed the circuit, you are not stopped the circuit. You are joining the circuit. Okay. So when you join, when you close the key, what happens? The charge flows in the circuit. Take the circuit. But we have said there is an induced EMF, is it not? So the excess charge is maintained. Excess charge is maintained by the continuous flow of electrons or current. By continuous flow of charges or current, you can say simply. Okay. Next one. Now let us move to the third question. What is the third question? Can you read? With K open and the rod moving uniformly, there is no net force on the electrons in the rod PQ, even though they do experience magnetic force due to the. So we have to explain this one. So listen to me. In the state when K is open, take down. When K is open, when K is open, when K is open, a force due to electric field. E represents electric field. That is due to the potential difference induced. Why this potential difference? Because as I already explained, at P there will be positive charges, at Q there will be negative charges. So between them there will be a potential. Okay. So the potential difference induced balance the magnetic force. Okay. So the potential difference induced balance, balance the magnetic force. So it means there is an equation between electric force and the magnetic force. Okay. So the force due to electric force, that is electric field. And what about this? The force due to the magnetic field, right? Got it? So we can call it, this is electric force and this is magnetic force. What is electric force? Electric force is nothing but charge into electric field, because we already know electric field is nothing but F by E. Do you understand? We already know this. So F is equal to E into E. So electric force on the left hand side. So let us write this as E into capital E. So this is electric force. This one is electric force. That is force due to electric field. What about this one? This is magnetic force. That is due to the magnetic induction here. So magnetic force. And magnetic force is given as here, that is FB is equal to V into V into V. Okay. So this is equal to V into E into V. Right. Now E, according to Ohm's law, E is equal to I into R. Right. And in this case here, the in terms of voltage, so here E is equal to, that is the uh, voltage across this length. Okay, so V by L. So you can replace this E by V by L. So E into V by L is equal to this BEV. This V is different from this. This is velocity. Now you can strike out both and you can have this V voltage is equal to V into V into L. Okay. So this is called motional EMF. Okay. That is different. V is equal to IR. V by L in this case, that is voltage per the that is length. It has nothing to do with this. This is different. So let me not introduce here. Okay. The voltage across the length, that is experienced voltage between the what? Length, across the length. Voltage across the length is taken as E here. Okay. No, 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 no. Then, so this is the explanation for this kind of what, when K is open, what happens here. Okay. Then, what is the next question? D. What is the retarding force? Okay, so they have talked about the retarding force. Take down retarding force. So when the key is closed, the current flows in a loop. For example, let me consider this is the length of the rod, and here across it you have the galvanometer here. It is closed now. So G, the current is passing through this in this direction. It goes like this. So here you have plus plus and here minus minus. And this is the velocity of the rod P and Q, PQ rod. And the force experienced here. Okay, so it will be occurring in this way because the current is moving, so it is in the opposite direction. So the velocity of the rod is further reduced. So when you apply another force, what happens here? There is a what? Retardation. Okay. So in this case, this is velocity. So when you apply the force on the opposite side, it experiences retardation, negative acceleration. Now we are talking about this magnetic field experience here. F, yeah, this is the magnetic force. This magnetic force is nothing but it is based on the current, how much current is passed through the circuit, and B is the magnetic field, then L is the length of the rod here. That is B. Therefore, and what is I here? I is equal to BVL that we already discussed, BVL divided by R. So BVL divided by R. So you can get this. So what is the value of B here? What is the value of B? BVL. That we already got 9 into 10 to the power minus 3. And what about the ohm? 9 into the. So it means 1 ampere. So the current is 1 ampere. Now based on that we can work out the magnetic force here. So Fm is equal to what is the current here? 1 into what is the magnetic field? 0.5 into length is 15 into 10 power minus 3. So what is the answer? 0.0 minus 2, not 3, minus 2. 0.75. Okay, so now we are able to calculate the force responsible for the retardation of the speed. Okay, then E, to keep the rod, how much power is required? Take down. So at constant force, okay, so what is how much power is required to keep the rod by moving 12 centimeter when it is when K is closed. So what is how much power is required? Okay, so the power, now we need to talk about the power. So power is given by, that is the force dot velocity vector. Okay, take down this. It is the dot product of force vector and the velocity vector. So let us expand it. So magnitude of force into magnitude of velocity vector, that is modulus of F vector, modulus of V vector, and you have to put cos theta, is it not? Cos theta. So it is said that that is how much power is okay, right? So E. So in this case, the what is theta? It is the angle between the force and the, what is that? The magnetic force and the velocity. So that is in along the line only. So the rod is moving. So the force is also in the same direction, means theta is equal to 0. Therefore, cos 0 is equal to 1. Therefore, you can take magnitude F and then V. Okay, so the power is equal to, and what is the force we have got? 0.075 into what is the velocity? 12 into 10 to the power minus 2. Minus 2. Now what is the answer? 9 milliwatt. That is 9 into 10 power minus 3 watt. Okay, so this is the power, right? Then let us consider the last one, F. If B is parallel, so when the B is parallel, it will parallel to the rails. For example, I said that is this is the direction of magnetic field, but our rod is kept like this. So instead of applying the magnetic field like this, now what is said? It is along the, it is parallel to the rails. So the rails are here. So if it is parallel means on the same plane. Okay. So if it is the case, what will happen? Means there is no movement at all. Huh? F. Okay. I moved to the G. Anyway, let me complete that one. So what happens is the B vector is parallel to which vector? The rails. Parallel to the rails means definitely no induced EMF. Okay. So no induced EMF. That is no motional EMF. It means it is a zero. And F, what is the F? What is the power in terms of heat? So power is equal to I squared by I squared into R. So we can apply this equation, and this I is 1 ampere, is it not? So 1 squared into what is the resistance? 9 into 10 power minus 3. This is 1 ampere. We already discussed. I 1 ampere. Okay. So 1 ampere in 1 squared into 9. It means the same. That is 9 milliwatt once again. Okay. So that is the power.